Hello, this is for pre-calculus. So make sure you go ahead and turn your books, make sure you have your book, but make sure you go ahead and turn to page 400. It's going to be lesson 5.1. I have to write that down. Right here. So lesson 5.1. So just make sure you have it in front of you. Make sure that the book is in front of you, and you do have homework. Keep in mind, everyone received this worksheet right here. So is this one right there. So make sure you have that. Numbers 1 through 18 of 5.1. So this lesson is an intro to trig. So again, whenever you see the pi symbol, it's not reference to pi, it's actually reference to radians. So you're gonna keep that with you. Keep in mind it's radians, it's not pi. So here, a little bit about this is it's a unit circle. You have this worksheet in front of you, or this piece of paper, we used it last year. So this in front of you is going to help you with a lot of these. But the reason why these coordinates work is because they all equal 1. So the unit circle says x squared plus y squared is equal to 1. So for example 1, it says a point on the unit circle. Show that this point, right there, is on the unit circle. So to show that, according to the equation, the x coordinate squared plus the y coordinate squared is equal to 1. So whenever you square them, you add them, you should get 1. So here, we know that the first one is always x, the second one's always y. So you go ahead and you set these according to the equation, plus this. And this all should equal 1. So keep in mind, when you're squaring a fraction, you always square the numerator and the denominator. So numerator again, and denominator. And this should equal 1. If you look at the numerator, they are radicals, but it's squared, so they cancel each other out, so you get 3 over 9. Plus, so that's for the first one, 3 squared is 9. Second one, these cancel out, you get 6 over 3 squared, which is 9. And keep in mind, left side, right side, it's an equation, so make sure your left side is equal to your right side, and they equal 1. So 3 over 9 plus 6 over 9, when you add them together, you get 9 over 9, and that statement is true. Here it says show that that point's on a unit circle. Your work is showing why it's a unit circle. So right there. Next one. So example 2. Locating a point on the unit circle. So you have this point, but you're missing another coordinate, you're missing y. So they know that it's on a unit circle, you just have to make sure and find it. So find what y is. So same thing, same concept, you're using the same equation, unit circle, x squared plus y squared is equal to 1. So for this, we have our x and we have our y. So for our x, we have radical 3 over 2 squared plus your y squared. In this case, you don't have a y, so it's just 1. So from this step on, you're just solving for your y. So continuing, we know that you square the top and the bottom. Plus y squared equals 1. This cancels out, the radicals, they all cancel out. So you're left with 3 over 4 plus y squared equals 1. So you go ahead, subtract them. Both sides, you get y squared is equal to 1 minus 3 over 4. And then you go ahead and solve for it, and the book has it for you because it's a squared, so you end up with y squared equals 1/2. You square both sides. When you square both sides, this cancel out. The reason why you're squaring it is because there's an exponent there. So it's not going to be the square root of 1/2, it's going to be plus or positive or negative 1/2. So for a lot of these, you have to make sure you're solving for them. It could be a positive, it could be a negative, it depends on the radians. So here, according to this, it's in quadrant 4. So the point that is on the unit circle in quadrant 4. So if you look in quadrant 4, you have the chart in front of you. According to this, so the positives of, and negatives, so that means these x's and y's, they have to be positive or negative. So if you look over here, the y coordinates are always negative in the 4th quadrant. So here it says positive or negative 1/2. So you have to keep in mind, it's going to be a positive 1/2 for your answer. I'm sorry, it's gonna be a negative 1/2 because all the y values in your circle, they are all negatives. And here it says positive and negative on the bottom. Keep in mind, we're gonna learn this later, but sine is always y, it's the y coordinates. Cosine is the x coordinates. And tangent is y divided by x, but we'll do that with a different lesson. The last one is finding terminal points. So again, if you're always referencing to this chart right here. So if you have a positive t, so for example, A says t equals 3 radians. So here, you have a chart here. If it's a positive number, so 3 radians is positive. If it's positive, then it's going to be working its way around the normal way. So it's going to be working its way from 0 and working its way around. If it's a negative, so if you look on example 3b, it's negative radians. So therefore, if it's ever a negative, instead of working the other way, you're going to work opposite direction because it's negative. So here, the first one, if you look in your chart, you start with 0, because you don't have anything starting here. Then you have radians over 2. Then you have radians. Then you have 3 radians over 2. And then you end up with 2 radians. So a whole complete circle creates 2 radians. And if it's backwards, because you're going this direction, so it's 0, there's nothing there. Then you go ahead and you're starting, you always start with radians over 2. So then you have negative radians over 2. Then you have negative radians. And then negative 3 radians over 2. And then you have the negative 2 radians. So your direction always changes. So example 3, find the terminal point on the circle. So you're finding a coordinate. So you're finding a coordinate in here. So example A says here, find the terminal point of 3 pi. So looking at the chart, you have here, you go back around, you know a whole complete circle is 2 radians. So that means for 3 radians, you're gonna have to go around just one more right here, and your coordinate for this one, because you're gonna add another radians to it, it's gonna be -1, 0. And that's it for your first one. So again, here, that's 1 radians. A whole complete circle is 2 radians. Keep on going, it's 3 radians. This is 4. Go again around, 5, 6, 7, 8, and keep going and going and going. B, the terminal point is negative radians. So that means it's a negative sign, you're going the opposite direction. So here, you should have 0. You start with 0, there's nothing there. Then you keep on going. We have a negative radian. So again, we're trying to find that coordinate in the end. So right here, the top part, the side right there. So you go down, and for negative radians, it looks like it would be on this coordinate here. And coincidentally, it's the same coordinate. C, last one. Terminal point, 4 radians over 2. Again, looking at your chart, radians over 2 is one of the numbers here. So you have radians over 2 here. And the coordinate for that, or the terminal point, is 0, 1. And that is all. So you're going around, and you're trying to find the terminal points for each one. And I'm sorry, it looks like it's negative radians over 2. So this would be a -1. So if it's negative radians, you're working your way this way. So it would be down here, 0, -1. So it's just gonna be down here on the bottom. Make sure you check for the negatives. So if you have any questions, go ahead and email me. But your homework will be 1 through 18. You're trying to find to see if those circles or those coordinates are on the unit circle. So again, you're gonna be using this equation here. Thank you.